In this video, I'm looking at Pythagorean triads. A Pythagorean triad are three numbers that are whole numbers that work with Pythagoras' theorem in a triangle. Here's an example here, 3, 4, 5. There are three numbers, they're all whole numbers, and they'll work in this triangle at the bottom. This side here will be 3. This side at the bottom will be 4. This side over here will be 5. So I'll write Pythagoras' theorem, a squared plus b squared equals c squared. Labelling my triangle, this will be c because it's the hypotenuse. This is a and this is b. Remember, the hypotenuse is the longest side and it's always c. So in my formula, I'm going to substitute in, and you'll see that 3 squared plus 4 squared is 5 squared. And that's true because 9 plus 16 does equal 25. So these three numbers here, 3, 4 and 5, fit into the equation and keep it equal. The left-hand side, the a squared plus b squared, does indeed equal the right-hand side. 25 does equal 9 plus 16. So that's a Pythagorean triad. All of these numbers at the top here that are in brackets are Pythagorean triads. If I try any of those, a squared plus b squared equals c squared, a squared plus b squared equals c squared, they'll all work. They'll all satisfy this equation. The left-hand side will equal the right-hand side. Here is a question with three numbers, and we're asked to find out if it's a Pythagorean triad. So what we do is we look at the formula for Pythagoras, a squared plus b squared equals c squared, and we assign the letters to the numbers. Now, the biggest number has to be c. The other two are a and b. Just be careful that you always make sure that the biggest number has to be c, the hypotenuse. Otherwise, it can never work. Let's see if it does actually work. So, if I substitute 5 for A, 12 for B, and 13 for C, I should get two things that are equal. I will start off by writing left-hand side equals A squared plus B squared equals 5 squared plus 12 squared, which is 25 plus 144, which is 169. Let's do the right-hand side. The right-hand side of the equation is c squared. So the right-hand side is c squared, which is just 13 squared, which is 169. Therefore, the left-hand side equals the right-hand side, and I've shown that this is a Pythagorean triad because it works with the equation. The left-hand side equals the right-hand side for these numbers. These numbers would make a triangle with sides 5, 12 and 13, and they fit the Pythagoras' theorem. Here's another example. In this one here, I'm going to mark C as being 13 because it's the biggest, and A and B as the other two. And let's start off, we write our equation, a squared plus b squared, or our formula equals c squared. That's Pythagoras' theorem. A is 5, the left-hand side is equal to a squared plus b squared, which is equal to 5 squared plus 10 squared, which is 125. The right-hand side is equal to c squared, which is equal to 13 squared, which is 169. The left-hand side is not equal to the right-hand side because 125 is not the same as 169. That means that this is not a Pythagorean triad. It does not make a triangle with a right angle with 5, 10 and 13. 13 is wrong. The answer needs to be another number besides 13. In fact, for it to be true, it needs to be the square root of 125. It would need to be 11.2. And because 11.2 is not a whole number, it's not a Pythagorean triad. Pythagorean triads must have three whole numbers. 5, 10 and 11.2 is not a Pythagorean triad, and neither is 5, 10 and 13. You can't make a Pythagorean triad starting with 5 and 10 because the third side won't be a whole number.